Hello, everybody. Welcome, ladies and gentlemen, to the technical stage of hydrogen and energy and fuel cells Europe. Sorry. We have a lot of interesting presentations, and I'm full. Very interested. The last presentation was so powerful, and we continue with the next subject. It's about circular material solutions for fuel cells, and we got the business development manager of Fraunhofer IWKS, Institute for Recycling and Resource Strategy, was a spontaneous translation. We got Dr. Sven Grieger. Welcome him with an applause on the stage.
Yeah, thank you very much indeed for the invitation. I would like to talk a little bit about a future project, which is recycling of fuel cells. You may think it's too far in the future, but as you know, future comes quicker than you expect. For example, 12 years ago, we founded IWKS, our institute, and at that time, you may remember that we had this rare earth crisis in the world. That means China raised the prices of rare earth elements, and at that time, some stakeholders in Germany said we need an institution who will take care of this and will save or will rescue the resources for German industry. And that was a kind of birth of IWKS. We are located in Bavaria and in Hesse, and our research focus is circular economy, and we develop solutions for that. We have different pillars where we are active in. Digitalization of resources. Here we combine ACA and LCCs, with crushing and separation methods, and plus some artificial intelligence methods to optimize in future the recycling of different products or according to economic criteria and ecological criteria. You know that the topic of CO2 emission or footprint is quite present, and here we have a solution for that. Bioeconomy is a big field, but I can say, for example, we produce hydrogen out of plastics material, organic materials, by a special method. It's called plasmolysis, but I can tell another opportunity about that a bit more. Energy materials, here come to the topic where we are in today. So we developed recycling processes for different components of electromobility, and it's batteries, fuel cells, photovoltaic as well. It's not electromobility, it's renewable energy, but here we're in as well, and electric motors. And we come to the last pillar, magnetic materials. So we can produce high-performance magnet materials or magnets from recyclates. That means old or taken back motors from the field. We have two, let's say, comprehensive activities as well with partners. And one is ZDR EMIL, a very funny name. It's a Center for Dismantling and Recycling of Electromobility Components. So here we look dedicated at the components of electromobility, try to dismantle it automatically, and trying to find the best solution for that. Oh, sorry, I'll start again. In the next comprehensive area is a high-performance center, green materials for hydrogen. We have a booth here in the Hessen area, so come to that if you want to learn more. So we want to optimize the use of hydrogen in production, storage, transport, and use in systems. So it's not about only recycling. It's about reliability and sustainability of all the elements that they are ready for hydrogen, of course. And we want to invite all stakeholders or interested parties which are active in this field, plus the results of ongoing research projects to transfer that into the industry. I come to the basic topic. What I want to talk to you about is the project Recycle I'm personally leading that in our institute. It's circular economy concept for fuel cells. It goes back 3 or 4 years ago when we had a discussion with the company Myrek, who is a recycler of precious material, and he said he gets sometimes old or used fuel cell systems, but they cannot bring it to the smelters because they refuse loads or shipments, whereas platinum in it, as well as fluorine, so Nafion membrane, you know, and so the generation of hydrofluorine in the process is very critical. So they refused the acceptance of fuel cell elements for the smelter, and so that company got a big problem. And then we've discussed a lot with different partners and founded or set up this project where we say, okay, we develop a recycling process for fuel cells, but we look as well into the design of today's fuel cells, so that they are in future hopefully a bit more recyclable. So that means process development and design development. And look as well into the topic of standards. Maybe you can standardize some design. Maybe you can standardize as well the recycling processes for the future. This project is ongoing. We are a bit more than halfway. Next year we will finalize, and then we will have a concept to do that. But it will take a time to get the let's say end-of-life fuel cells from the field. However, we have to be prepared. As I said, when they really come back, we need a solution, and we developed that. A bit deep dive into the project. Don't go too deeply, but what we have to do is first we have to dismantle the whole system. Maybe pre-crushing. So we are still in the project phase. Try out different methods, different ideas, and in the end. Something goes wrong here. In the end, we need some chemical treatment or alcoholic solutions or others where we take away the catalytic layer from the Nafion membrane and generate very pure Nafion. You can see it at the booth. It's like a transparent foil, you can see, and the catalyst layer where we leach out special elements like platinum. Here we did at the first stage some dismantling tests because we are really newcomers in this field, and try to dismantle it and try to get the MEA here. It took about 10 minutes for the whole stack, and we tried. It took 10 minutes, and per cell we have roughly 0.1 to 0.5 gram platinum, and this should be recovered. We tested similar methods here. One is electrohydraulic fragmentation we use for the recycling of batteries. It worked well for batteries, but not so good, unfortunately, for fuel cells. But okay, we have some other solutions in place or other ideas. What we see here in the REM pictures, which is quite interesting, that even if you remove the catalyst layer, you have still some platinum. Okay, platinum of course, but still some fluorine freight in this layer. That means we need another solution for the layer to recover the platinum before we bring it into the smelting process. And so we tested, and we are still testing different methods, mechanical methods. Okay, that didn't work here. That didn't work well. But we are quite successful with organic solvents, so leaching or getting the layer from the membrane. And in the last step, we try bioleaching. It's still in operation. I've no results yet, unfortunately. But it works well with concentrated hydrochloric acids. This works very well. So we come above 90% recovery rate. And now we have to tackle a few other questions. So that means, can we observe the degradation of fuel cells? Can we do a pre-treatment a bit more downstream, or let's say more with crushing systems, assembly by robots. If it comes to more take back of these products, but at the moment we are in a situation where only a few cells come back. So that means manual dismantling is okay, but we expect in 5 to 10 years we have to find a solution for more automatic systems. Yeah, that's from my side, a very brief run through the topics. So see you at booth C40 to learn more about fuel cell recycling and our project on green materials for hydrogen. Thank you very much for listening.
Thank you very much for this interesting presentation. Are there any questions from the audience?
Thank you for the nice presentation. I was wondering about the bipolar plate. Are you thinking about recycling these materials as well?
Yes, of course. It's another topic. At the moment, we are discussing that internally. But we have learned that there are new ideas of making these bipolar plates with thermoplastic and with carbon. So, and we talk with makers of that, how to bring that back to the production. So that's of course an issue. Yeah.
Okay, thanks a lot for this presentation.
Okay, thank you.
Dr. Sven Grieger, you just jumped in for a colleague.